Yo, what's up? I solve every single problem. This is something you should know. This is 2697 lexicographically smallest palindrome. Okay, let's go ahead and get right into this problem. So you're given a string S consisting of lowercase English letters. Okay, so very confined to what the system can be. We have this string S, and S only contains A through Z lowercase. You are allowed to perform operations on it. Cool. I love operations. That's cool. That's cool. In one operation, you can replace a character in S with another lowercase English letter. Okay, so if there's an A, I can replace it with a B or C or a D or an E or an F or G, but I can only replace lowercase letters with lowercase letters. So whatever I do to this string, it's always going to be lowercase letters. Your task is to make a palindrome with the minimum number of operations possible. If there are multiple palindromes that can be made using the minimum number of operations, make the lexicographically smallest one. Okay. String A is lexicographically small. So there's kind of two things we need to understand if we're doing this problem. And since we're doing it easy, it's fair to assume that if you're watching this, you may not know, these simple but constantly showing up in kind of obscure and in outside of the realm of normal things that you do on a day-to-day basis, right? It's fair to assume you don't know what these things are. So first, what is a palindrome? Okay. A palindrome is simple. Okay. A palindrome is a word that is the same reversed. So a word is a palindrome if you take the word and you reverse it, and it's the same. So some popular palindromes are, for example, race car. Okay? Why? Well, what is race car backwards? Well, there's an R, then there's an A, then there's a C, then there's an E, then there's a C, then there's an A, and then there's an R. And wouldn't you look at that? Race car reversed is race car. So a word is a palindrome if it's the same backwards, right? For example, my name is Ben. My name is not a palindrome. Why? Because Ben does not equal Neb. Right? But if my name was Bib, then it would be, or whatever. So I think you understand what that is. It's pretty intuitive. So race car, mom, dad, right? Any word that's the same when you reverse it is a palindrome. If it's not the same when you reverse it, it's not a palindrome. Okay? So now we understand what that is. Let's think about what a lexicographically smaller string is. A lexicographically smaller string, we'll look at the formal definition in a moment, but kind of the simple terms you can think about it is lexicographically the lexicographically smallest string is a string that would come what? A string, if you looked at a dictionary, right? A dictionary is sorted lexicographically. So a lexicographical string, S comes before T if S would come before T in the dictionary, right? So for example, if we had string S equaling a different color, let's do that. Let's say S equals dad. Let's make this D lowercase. S equals dad, okay? And let's say T equals data. Okay, well, which one of these would come first in the dictionary? How is that game played? Well, you look at, the first letter and you say, okay, they're the same. So they both be in the D section. You look at the second letter, you say, okay, well, they both be in the DA section. And then this first letter that's different is this D and this T. So which one comes first? Well, dad would come first because D comes before T, right? So it's the first letter that's different. Whichever one comes earlier in the alphabet will come first in a lexicographically sorted system, right? So a string A is lexicographically smaller than a string B if the first position where A and B differ, right? So the first position where they differ is this D and this T, right? String A has a letter that appears earlier in the alphabet than the corresponding letter in B, right? So D comes before T, so that means dad would come before data. All right. So those are those two ideas. Those are kind of the only two basic ideas we need to understand just to comprehend what it is they want, right? Because we have to know what a palindrome is, know how to create one. And we have to know what a lexicographically smaller string is in order to determine the smallest lexicographically smallest string, which is a palindrome. Whew. Return the resulting palindrome string. Okay. So in this example, we're given example S equals EGCFE, okay? EGCFE. Now, in order to do this problem, we're going to have to convert this string into a palindrome, right? So in order to convert this string into a palindrome with the minimum number of operations, well, in order for something to be a palindrome, what does that mean about the letters in relationship to each other? Well, why is race car a palindrome? Well, because it's the same it's like a mirrored image of itself, right? And what I mean by that is, well, if I'm going to reverse it, what does that mean? Well, this last letter, right? This last letter becomes the first letter, right? So that means that if the last letter becomes the first letter, the last letter and the first letter are going to have to be the same, right? These two have to be the same in order to be a palindrome, because I'm going to take this letter and move it to the front. So in order for it to be the same, it has to be the same as the one in the front, right? And that would be the same for the second letter, right? This is a palindrome because this letter is going to get reversed, right? So this letter will go to the second to last place. So that means that the second letter and the second to last letter have to be the same, right? And these two letters have to be the same. And then there's kind of a unique case with the one in the middle, which can be anything, right? Right? Because this isn't going to flip positions, right? When I reverse this, what does that mean? Well, this last R will go here, right? Which is why they have to be the same. This last A will go here, which is why they have to be the same, right? They have to be the same from the initial. This C will go here, which is why these C's have to be the same here. But this E doesn't move, right? Because it's in the center. So when it reverses, it's still in the same spot. And this E goes here. And now this C will have to go here, so they have to be the same. And this A has to go here, so they have to be the same. And this R will go here, so they have to be the same, right? So there's kind of this symmetry about palindromes with respect to the center, right? Because with respect to the center of the string, everything to the left and everything to the right have to be mirror images of each other, right? So that's what we can do to look at a string and turn it into a palindrome, right? When I look at this string, well, I play the same game, right? I look at the first letter. In order for it to be a palindrome, well, the first letter and the last letter have to be the same, right? Which they are, so I don't need to change anything. Now, when I look at the next letter, they're different, right? Now, I'm going to do this in the minimum number of operations, right? If I wanted to make this string as small as possible, I could just convert them all to A. And a bunch of A's is definitely a palindrome, right? Because 5 A's in a row is the same as the reverse of 5 A's in a row. But I have to do the minimum number of operations. So if I'm doing the minimum number of operations, I only changed one of these, right? Because I'm talking about the minimum number of operations to make this a palindrome. If I had infinite number of operations, then I could change all the letters to A, right? But since I have the minimum number of operations, I can only change one of these to turn into a palindrome. So then it becomes a question of, well, do I change the G into an F or the F into a G, right? Now, what you want to do here is, well, you would want to turn the G into an F. And why is that? Because we want the lexicographically smallest string, right? So if we have to convert, right, if we have to convert, if we have to change one, if we have to change one letter, right? If we have to change one letter, no matter what, right? We're in this position where it's not a palindrome anymore because they're not the same, right? Because they have to be the same mirrored into the center. So since they're not the same, I have to change one of them. So I'm going to change it, then change it to be lexicographically smaller, right? If I have to change it, I might as well make it, I'm going to need to make it the lexicographically smallest one. So what will make this lexicographically smaller? Well, G comes after F, right? So if I convert this G to an F, then the string will be smaller, right? But if I convert this F to a G, the string is going to come later in the dictionary, right? So I should always take the larger one of the two and convert it to the smaller one. And doing that will give me the lexicographically smallest string, right? So when we're dealing with this next example, which is a perfect candidate to kind of prove this point because it doesn't have both of them, damn it. Let's look at now 7. Because we're always changing the first one, right? Okay, so for A, B, C, D, I won't walk through it, but like you look at A and D, right? A and D, in order for this to be a palindrome, they have to be the same. So am I going to change a D to an A or an A to a D? If I change an A to a D, that's going to put me way farther in the dictionary, right? I used to be in the A section, now I'll be in the D section. Versus if I change the D to an A, well, now I'll be in the ABCA section instead of being in the ABC D section. Right, so it makes sense to always convert the larger string to a smaller string because the closer you are to the front of the alphabet, the higher up you'll be in the dictionary. And if they're not the same, you have to change them regardless. So you are going to change it to the lexicographically smallest one. And the lexicographically smallest one is the one that comes earlier in the alphabet. So whenever you look at a letter, just say which one comes earlier in the alphabet. I'll change it to that. Right? G comes after F, so then G should become an F because F comes before. Because I'm trying to make this thing lexicographically smallest as possible. Come as soon as possible in the dictionary. Okay? So what we need to basically do is look at each string of I and string of the length of the string minus I plus 1. So what I'm saying here is we look at each of these characters, right, that need to be the same, right? The 0th and the -1 need to be the same, right? The first and the -2 need to be the same. So I'm basically saying, look at the 0th and the -1, and the 1th and the -2, and the 2 and the -3, right? Like this, like so. And find the string that's going to, if they're not the same, then replace the one that's larger with the one that's smaller. So look at each SI, AI pair. So we'll look at each of these pairs of strings that are supposed to be the same, like the reflective strings. And then we'll say, change the larger one to the smaller one. And that's it. Now, we don't need to go through the whole string, right? Because we only need to go all the way to the center. We don't need to go past the center, right? We just look at R and R and A and C and then E. Right, but we don't need to then look at C and C again and A again and R again, right? We only need to do it once, so we only have to go halfway through the string, all right? So let's go ahead and do that. Now, since we're dealing with a string, we can't change the letters of a string in place, right? So we're going to convert the string into a list so we can easily modify the characters. And then what we'll do is we're going to look at each of these pairs, right? So how many pairs are there? Well, this is length 1, 2, 3, 4, 5, 6, 7, right? So there's 7 characters to look at, and there's 1, 2, 3, 4 pairs. We don't really need to look at this center pair, right? We just need to look at these 3 pairs, right? Because there's a pair for the R's, a pair for the A's, and the pairs for the C's. We don't need to look at this E because it's just the E by itself. So if we do 7 floor divide by 2, we'll get 3 pairs. So if we floor divide by 2, we'll get half, right? Because we basically cut the system right in half. If we can't cut it right in half, well, we don't need to concern ourselves with the center letter because when it's reversed, it'll be in the same position. So it doesn't need to be changed, and it can't be changed because if we changed it, then technically we'd be adding an additional operation we don't need to do, so it wouldn't be the minimum number of operations, okay? So we'll look at each I, in range, length of S, floor divide by 2, all right? Because we only look at half of the letters because there's, we look at all pairs of 2. So we look at the outmost 2, the next one's all the way to the center. So it's half, right? And then we just make a calculation. We say, well, if the order of S at I is greater than the order of we'll do negative I plus 1, right? And we'll just we'll pass for now. Let's actually just print this information so you can see kind of what I'm doing here, so you can ensure that I'm, grabbing the right pairs. Never a bad idea to do a little debugging while you're solving the problem. Right, so I should see E, E, G, F, and that's it. Right, on two different lines, E, E, and G, F, right? We don't need to worry about C because it's in the center. It's not going to flip, so that's fine. But then we need to play this game. Well, if the order of mine is greater than the order of the other one, it's basically your location in the alphabet. If I'm further in the alphabet, then I should become him. Right? I'm further in than the alphabet than the other one, so I might as well change to him. Otherwise, either we're the same, so if I swap them, it's not going to break anything, or I'm less than him, so he should become me, right? I come before him, so he should become me. And then at the end, we'll just turn this thing back into a string by hitting a little join and running that. Okay. Boom. Hit it. And there you go. So, what is the time and space of this? Well, let's say n is the length of s. For time, well, we convert s into a list, so that takes n time because it's the length of s. We look at half of the string, and then we do constant operations, right? Define this as constant, constant, setting this as constant, setting this as constant. So n time to create this list, n divided by 2, so n over 2, or big O of n time to find this, the operations we need to do, and then we join it at the end, so that's another n time because we have to convert it back into a string. So that's big O of n time. For space, well, we have to convert s into a list, so we're creating an additional list of size n. I wanted this to be O of 1 space, but the problem is how are we going to modify the swaps without creating a list to efficiently do it, right? I don't know how you would do that. Maybe you could make this so it's O of n. But maybe you can make it O of log n if you, I don't know. You'd have to find a way to kind of intelligently keep track of, what is and what isn't going to be swapped. But that seems a little hectic. I don't know how you're going to get this to O of 1 unless you want this to blow up because you're going to be dealing with strings when you update. Okay. That's it, everybody. Boom, boom, boom. Hope you have a good day. Bye-bye.